Okay, so let's start. The working software. This is the episode 0, the first episode, the initial episode of the series. I hope a series of live talks. So, okay, I will explain you why streaming and why this name. Why streaming? The reason is simple: economy. When I prepare a conference talk, it costs me some maybe 30-40 hours to prepare 1 hour talk. If you add traveling there, it goes to 50-60 hours of engagement to only produce 1 hour of materials that you can view. When I'm preparing video courses, it takes again 60 hours per 1 hour of video course. That is the reason why I can only produce some 3 or 4 courses per year. I simply don't have more time for that. And then I have a lot of materials to display. I have a lot of topics, many topics to talk to you about. And I don't know, streaming was one of the ways out of that trouble because, for example, this session today only costs me about 5 hours of working to prepare. So it's simply the economy of delivering content, the reason why I'm streaming. There are other motivations out there on the internet. I'm not going to I don't know. You will see which category I fit into, and you will see if these streams I will deliver will be of any use to you. So if they do, please watch them. On the other hand, you should be familiar with the concept of this economy I've been talking about. This way of talking is cheap, effectively cheap. It costs me very little to deliver a talk in a live stream. And when something is cheap, it will obviously look cheap. You see this screen, it costs me nothing to produce it. You will not have the quality you usually have from conference talks and from video courses. So get used to it. And so the substance. Why the name? Why working software? Working software is the concept that has always been fascinating me for the last couple of decades. It obviously comes from the Manifesto for Agile Software Development, which you are familiar with, I'm sure. One of the 4 basic pillars of Agile software development is the working software. The working software is something that your customers need. They don't need your emails, they don't need your documentation, they don't need your promises, I don't know what. They need software that works and software that does things they need. Everything else is futile when speaking in software, in software development terms. The other 3 items in the manifesto are individuals and interactions are more important than processes and tools. That is perfectly right. I actually never knew these processes and knew very little about tools. Even when I was a senior manager, I think it was my job to install processes and management tools into development, I never did that. But what the teams I was managing did was to deliver a working software. And that was my job as I saw it. The 3rd pillar is customer collaboration. I will not talk in these live talks, I will not talk about customer collaboration directly, but we will sometimes touch it because it is important. Simply, customer is going to use your software. Customer is paying you money to deliver software. On the other hand, it's a difficult topic, and I will really not dive too deep into it. I'll give you a few hints. If the customer if a customer has wrong attitude towards software, the customer will ask you to develop something that is not software. And that is bad. If customer expects you to collaborate via email, then no, that is not collaboration. So this is a difficult topic. We will come to it from time to time, and I will give you a few hints about what I think about customer collaboration in the future. And then responding to change. Responding to change is essential in software development, because if you don't, your software will be poor. Change is everywhere in software. It means that even if you write software today, those lines of code you're writing will be affected by what you learned about the domain yesterday. You don't wait for another meeting in a week or a month to decide to apply something that you learned about business yesterday. You apply today. So responding to change is essential, and you will eventually adopt practices in everyday programming which are helping incorporate change, everyday change in everyday programming. Responding to change is indistinguishable from producing a working software. Okay, so much about agile software development. I will show you in the next live session, I will show you one example of software which is being developed in agile manner, and you will see what all these things mean in practical code. But if I made you believe that I named these talks working software because of the Agile Manifesto, that is only partially true. The real reason, where are you? The real reason for that is actually this book. I'll show you that. The Working Brain. The Working Brain, a book published in 1973 in US edition. This is one of my all-time favorite books, and it taught me a lot about human mind. It is an introduction to neuropsychology. Neuropsychology appeared some 50 years ago as a result of experimenting on animals, first on animals. You have heard about Ivan Pavlov, the Pavlov reflex. Psychologists were examining how animals react on inputs. And they made some conclusions, all right. But a part of the team that worked on animals came up with an idea, with a thought that says, well, humans don't react to stimulus the same way the animals do. They're more complicated. And so they established another group, and for another 20 years they were examining human brain and came to a very interesting rule which explains how humans think. I'll get back to slides, and I will show you, I will hijack slides from one of my previous videos, video courses. This is taken from that book, The Working Brain, and this is the substance of the way we humans think. Now try to see this from perspective of software development, and you will start seeing where I'm heading. What they concluded about people, about a man who is being given a task. A man is acting differently compared to animals. And here are their words. Man not only reacts passively to incoming information, so it's not that you hear the request and you jump onto it right away. No, you sit down and listen. but creates intentions. So you create intentions, what you want to do. You form plans and programs of actions. You will plan future actions, inspects their performance, and regulates behavior. That is important. We are regulating our behavior as we progress, working on some problem, on solving some problem. We are regulating our behavior to stay in the track which we have already planned before, so that it conforms to these plans and programs. Finally, he verifies his conscious activity, comparing the effects of his actions with the original intentions and correcting any mistakes he has made. This process is the human process of solving any problem. If you see it said that way, you will recognize this process in the way you are going to a shop, working on any project item at your work, or doing anything else, going to vacation. This is the process you perform. And it hides a few goodies that are not so obvious. Well, one of them is that after you do something, after you complete a project task, you will compare the effects of what you did with what was asked from you. Is that what I was meant to produce? If no, then you get to step 1 and start over again on a difference between what you made and what you did, what you were meant to do. All right? So you will progress once again through this complete loop and fine-tune your solution. So this intention, plan, regulation, verification, this loop, which is basically a human loop, human way of thinking, is so natural to us that we can copy it to software development and use it as is, and we will feel great. When you don't feel good developing some feature, or when you see someone not feeling good in development, you will recognize that this loop was broken. Some actions were erratic, not conditioned by any input. People are doing random things. People are choosing platforms and choosing libraries and technologies and even programming languages randomly because they heard something. They don't take any, there's no plan. This second stage, no plan in their action. And then they suffer. Okay, there is nothing to regulate because there is nothing to compare to. You cannot compare where you are with any plan. I think I've got the point by now. So if you are developing software, you will gather the requirements or pick one requirement. You will analyze it, make a plan, you will implement it, that is the regulation, you are walking the path and trying to stick to the idea you had when you started, and eventually you will verify what you did. This is typical in software development, but this slide has one trick, well, look. This looks very complicated. It's the whole building. And you're not planning to develop the whole software right away, in one go. No, you don't do that. This same slide could work the same and look the same if there was only one box here to develop. So you can apply this model of thinking to any proportion you like, to an entire project, to one application, to one feature in the application, to one line of code that is part of one feature. In the next live stream, I will effectively show you the development of one tiny feature in one incomplete software. And you will see that this thinking model can be applied directly to to development of any piece of software. Now, back to this book, right? The Working Brain. It is fascinating me. It has always been fascinating me because it was those scientists were analyzing the human mind, the being of a man, through neurons, through hardware. How does our hardware make our mind? And if you like those kinds of stories, you can read on neuropsychology. It is a very interesting area of science. But what I wanted to tell you, there is one very interesting fact about their job. You may be puzzled by this question. How does a scientist know what is the precise use of one group of neurons, of one path in the brain? How do they know that? That is the puzzle. And there is a gruesome answer to that question. How did they know that? You should remember when they were investigating that, and that was after World War II. And what happened at that period of time is that there were many people who were injured in war by pieces of metal and bullets running through their heads. So that is the gruesome part of this science in its beginnings. Actually, there were many people after the war with the parts of their brain being surgically cut off. I'm not sure that this is funny. So the scientists could effectively take a subject, see which neuron paths were cut off, and figure out which part of the mind is missing in that man. And so they built an entire model after thousands and thousands of subjects passing through their hospitals. They have built the model of our brain, the working brain. And now you say, why are you talking about the brain? And I say, no, I'm talking about software development. You can tell the usage, the utility of a design element. You can tell it best when it is missing, when it is cut off from the rest of the software. This is a bit of philosophy. You may agree or disagree with me. It's not too important. But my point is that you can best see design principles in software when you don't have them, and you have to devise them. Software development is not a religion. Nobody is telling you how to perform. There's no dogma in software. Nobody is telling you how to implement this feature or that feature. You are making decisions, and you are making decisions by observing what is missing in your software. In the feature you're developing, in anything, in one line of code, what it's lacking, what does it need to start working, and then you build that connection, that path, that data path, that decision path. And that would be about all. Again, I will show you on the next meeting one concrete feature, and you will see this way of thinking in motion. Today I'm not going to show you any code. I just wanted to warm up. I wanted to learn to use this wretched software for streaming and all the stuff I have on the desk. So this was just a warm up. Before we split, I will give you a precise definition of software, of a working software, because I will have to draw a heavier axe for that. Okay. I will draw something for you. I want to draw you how software appears. Let me get more hardware here. I want to show you how software comes into being. So you have that poor guy, which is your customer, okay, not knowing what they are doing. The customer is running a business. Okay, the customer is running a business for 100 years in a very same way, or basically the same way for centuries, using very primitive tools to accomplish that. Tools which are quite different from what they are asking you to build for them. So they use mostly pencil. Okay, this is the tool. And what they ask you to do is to come up with a nice and square piece of software. Okay, and you do. So the customer asks you to develop software, and you do, and you want to replace this. But when the customer gives you the requirements, when the customer tells you what he wants, he actually cannot distinguish these two things. They normally see your software as a very fast pencil. And that is the problem. They see no distinction between these two. And if you view software development today, you will invariantly see programs working exactly the same as a paper business, with one tiny distinction, that it is somehow automated, and that's why customers see you as a very fast pencil. Do you want to write that? Do you want to develop that? No. But what do you do? How do you respond? How do you act? What is your interface towards your customer to stop this from happening? Let's start again. Your customer, I'll write it again here. Your customer has many thoughts in his mind, and he is utterly lost. Okay. And he has a business. But that's not relevant to you, because nobody wants to have a business. People want to have a vacation, not business. They have something else that you need to discover. They have something that is quite different from everything else you have ever seen in your programming life. They have a problem that is hurting them. Their business is solving the problem for their own customers. And that is the whole point of businesses. And where does the software come? The software comes as a representation of a solution to the problem. So you would move the problem away from the customer and put software in between. And software then becomes a layer of abstraction between the user. I'm interchanging the word user and customer, and there is difference. User is the guy who is using your software, and customer is the guy who is paying you to develop software. So that is the difference. But anyway, they will use your software, and your software is supposed to abstract away this pointy thing here that is hurting them, so that this thing doesn't exist in their view anymore. And then comes the question, how do you avoid this fast pencil fallacy? You avoid it by understanding that software is of no interest to your customer. The problem has been abstracted away, so it's of no interest anymore as well. what is of interest. The way the customer or the user is giving commands to your software is the way the customer or the user is controlling this abstraction of the problem. You need to think about that. And the software is producing one tiny thing, which is the only thing your customer is worried about and wants to think about it. That is the output. So this output here is the only thing that is useful to your customer. Software is not important. Problem has been abstracted away. The output is what counts. And you will effectively develop software in such a way that the customer, that the user, okay, I will switch to user now because it's the one who is using software. You will switch to mode of thinking about how you can let somebody use your tool, the software you have built, to produce the only thing that is useful to him. And that is that output. And in that way, all these things below this very thin line under the user interface, all this becomes your own problem, not customer's problem. They won't see any of these. Only you will see it. And it is your domain, it is your job to develop that. So developing a working software is to develop this interior here in order to have this abstraction there. And then your software will not be a very fast pencil, but it will turn the tables and it will do the right thing, whatever it is, to solve the problem for the user. I will give you one interesting example. One example that is also interesting to me. I'm not sure whether you're sharing my my fascination with some problems in the world. Sewing machines that are sewing cloth like this here. I'm sure that you are wearing some clothes right now, so you all have stitches on your cloth. Well, machines that make those stitches were developed to mid-19th century. Back then there was a war on patents. Many people were thinking how to replace people sewing, what was the word? Cloth. There were even riots back then. So 200 years ago, there were riots because machines were replacing people and taking their jobs. You know, the same thing happens today. Again, I'm not sure whether that is funny or not. But anyway, the sewing machine guys were trying to invent a machine which can replace a man who is pinching holes with a needle, then grabbing the needle underneath and going up and down all the time. And by the way, very important thing, while doing that, a human had to make some specific stitch so that it holds in place, in one place, and those sheets of cloth hold together. That was sewing, and I don't know how to pronounce it. Anyway, what they came with in the end, after some 30 years of experimentation, was an ingenious invention. Very simple. The sewing machine has a needle with an eye in the front of it, not in the back. That is the difference between manual sewing and machine sewing. The position of the eye. Because the eye must go through cloth, but the needle must remain above. Go and read about the history of sewing machines and you will see it's exceptional history. The point of that invention was that the inventor has effectively discarded million years of history of manual sewing cloth and replaced it with something completely different. Even the patent, which has brought a lot of money to its owner, even the patent was about having an eye at the front of the needle. It is one of the most elegant patents in history. A man has basically patented a hole, a portion of air, and got huge amounts of money on that. Why I'm telling you that? It's because the inventor there has proven one very important principle which you should apply to software as well. It doesn't matter how people are doing stuff by hand. You can learn from that, but that is not the law for you. You don't have to replicate that in software. If you look at your shirt, you will see that stitches consist of 2 threads, while manual sewing uses only 1 thread. So they have substantially changed cloth stitches in order to make a machine which can do that. They could not develop a machine with 1 thread. So they were thinking outside of the box. They have discarded thousands of years of manual sewing and developed something completely new. That is your job as a developer to do. To disregard the way a business was run for the last 200 years, or I don't know how long, it depends on the business, and to develop something new that is constructed out of the problem, and to look at the user and make a utility, make something that is useful to your user and your customer. I hope this was not boring. I will end here. Thank you for watching this introduction. Next time I will appear in 2 days, same time in 2 days, and I will show you a piece of software which is under development right now. It is disgusting, but it works. And I will implement one feature which it is lacking right now. I will explain you the reasons why and the methods how. And you will see all these principles in action. Again, thank you for watching, and I hope to see you again in 2 days.